For the first session I'm introducing here, it's focused on private space exploration, some of the kind of highest aspirations of many people in technology and engineering. It's an extremely active area these days, as many of you know, with Elon Musk, the SpaceX project, just landing a rocket on a barge, and Jeff Bezos with Blue Origin, and Richard Branson with his project. So it's really become an area of tremendous interest from some of the top entrepreneurs in the world. And the advances in kind of cost and practicality of doing space travel really promise a true revolution in the years to come. So it's a pleasure to introduce Robert Böhme with the Mission to the Moon Audi project. He is part of a group called PT Scientists that's been working on this for some 8 years now, and we're very excited to see the progress they've made so far. Robert?
Okay, hello everyone. I'm Robert from the Part-Time Scientists. Before I talk way too much to you about space explorations and things I'm really excited about, I want to show you a very short video which hopefully excites you and brings up some questions that I can answer to you.
The moon, our closest neighbor in the solar system, and yet it has always seemed distant and unreachable until now. Now, a private team of engineers is working to change that forever. They come from different backgrounds, countries, and fields of expertise. But what unites them is true pioneering spirit and the will to try the impossible. Who are these guys? They are the part-time scientists, and they are full-time crazy. Audi engineers are supporting them to build and test the Audi Lunar Quattro to make it ready for the moon's challenges in the context of the Google Lunar X Prize. Together, we will take collaboration and teamwork further and reach for the stars. Wherever this mission may take us, together we are following the true meaning of Vorsprung durch Technik. Join the part-time scientists on their mission, the mission to the moon.
Okay, so now if I've showed you a lot of things already, and so you know about something from Google and some private guys who might obviously, or to your own opinion, be either crazy or hopefully pretty cool, sending something to the moon. So what does this have to do, what's the context for this? So before I tell you about this challenge that we take part in, I want to remind you of something which happened almost 100 years ago. So this guy that you can see here in the background, you probably know the guy. That's Charles Lindbergh. This is the first man who ever crossed the Atlantic Ocean with an airplane. And the reason why he did it is, and that's something that most of the people don't know about, because it was a prize challenge. So he was taking part in a challenge which is called the Ortiq Prize, set out by a hotel owner, Raymond Ortiq. So, and by the time, that Raymond Ortiq lived, he was having, having his hotels with a lot of pilots being in there. And by the time aviation was something completely, out of the league for the average guy. You couldn't just jump into a plane and travel somewhere. So the point is that back then, pilots considered crossing the Atlantic to be an impossible thing to do. So, but Raymond Ortiq itself, a man, who went from, still in his 20s, he was herding sheep. And so he went from, someone who herded sheep to become one of the biggest hotel owners of his time. So he didn't simply believe in the word impossible. So what his idea is that he set out a prize and said, okay, whoever proves to me that it's possible to cross the Atlantic gives a big share of money by the time. So, and the idea is that back then, about 600 to 800 people tried to win this challenge, which was called the Ortiq Prize. So there was much more guys than Charles Lindbergh, and a lot of these guys, sadly, to the sad facts of history, they failed with their attempts. They actually died trying. So they tried to cross the Atlantic and they drowned. They crashed into the ocean, so they didn't make it. So you only knew about the guy who won the challenge. But the idea is that these 600 to 800 people who are worked around the globe to win this challenge, they developed and tested out a whole new set of technologies for building sorry, I always saying spacecrafts, to building airplanes. And they tried different concepts, like with multiple propellers, with one propellers, multiple decks, one decks, and they're asking themselves the questions, how can we make it possible to cross the Atlantic Ocean? So, and this technical development was the biggest achievement mankind ever made in the fields of the aviation industry in just 5 years. So that's why we call it, if you look it up on Wikipedia, that's why it's called the Lindbergh boom. So, and the idea is that, that's the idea behind the Google Lunar X Prize. So the two founders of Google, you know, they're seeing space exploration as it's today, and there's a lot of cool stuff happening, as we just heard, for example, with SpaceX, which is a private company where you can actually just buy a rocket and launch something into space just privately. So, but the point is there's still room to do more in space, because right now we have a rover on Mars, you know, the Curiosity rover, which is kind of nice. You know, it's really nice to know that you can send something to space, but the problem is that this is just one rover that we sent to Mars in a 10-year time frame, and when this rover was sitting on a launch pad, most of the technology inside this rover was already 12 years outdated. So from the point of view, in this case, it really means that space hardware really is, right now, if you look, for example, on this rover on Mars, it's kind of the most modern thing that you have there, but the only reason why it is so modern is because it's the only thing that you have there to compare it with. So the idea is, how can we make space exploration in a way that much more things are happening, that things are happening quicker? And that is the idea behind the Google X Prize. So it's basically, the X Prize is a simple thing, by the way. So basically the two founders of Google, Larry Page and Sergey, they said, whoever gets to the moon gets $30 million from us. So what do you need to do to grab this $30 million? So you know, I was seeing this, this announcement for this competition in 2007. And yeah, to win this prize, it's actually quite easy. You need to get to the moon, drive 500 meters, and send back HD images. Sounds easy, right? Because you know, if you look at it, you know, we've been to the moon before in the 60s, so why should it be so complicated? Driving 500 meters, you know, you drive much more distances with your bicycle or your car every day. And then sending HD images, yeah, you have an HD phone in your pocket, so should this be a problem? And that's the key here. So that is what I was seeing in 2007, and the question I was bringing up for myself is understanding the technical challenges. Each of these items that you can see there is right now an impossible thing to do. You know, privately sending something to space is something that nobody has ever done before. Privately landing on the moon, never done that. Privately, or having a rover, a self-built rover, drive on the surface of the moon for these 500 meters also has never happened before. And HD images, they're not just something special from the image quality, but this problem here is the communication. It's not about taking the pictures, but actually getting them across the 400,000 kilometers back to Earth. So, so who are we? So we are the so-called part-time scientists, and we're a team of scientists and engineers, a private group of people that I brought together in late 2008. So it's basically, most of the time, it's a group of friends where I started out with six engineers and scientists. And we've now grown to 35 people. And our group, we were working really closely with institutions like the German Space Agency, like universities, you know, like a number of universities in Germany, but also outside of it. And of course, we've partnered with Audi for the technology and mission support. So we're developing all of the technology together to get to the moon. So that is what the team looks like as of today. And this is just a very recent picture that I took. And you kind of cannot really, I don't know when to introduce all of them to you, but what is interesting that I think you can immediately realize who's the software developer in the image. If you can spot him, then you can come to me afterwards, and I might give you like a present or something. So, but otherwise, this is the team that we have of today. And yeah, we mostly work out of Berlin, Germany, and out of course from the Munich area, so Ingolstadt, and also in Salzburg. And something which is pretty cool. So I've been telling you about this Google X Prize. So this is an international challenge where a lot of things has happened. When this competition started, 34 teams registered initially, and about 2 years ago, it was down to 16 teams still in the running, trying to win this challenge, to be the first one on the moon. And Google was trying to help get the teams forward. So they announced the so-called interims prizes. So they were looking for the top 5 teams running in the competition who are the technically most advanced. So, and something that I'm really proud of is that, as a private group that we started out with, that Google selected us to be evaluated, for this, to be amongst these top 5 teams. And then they followed us for 1.5 years, really testing out all of the technology, following us to all of the test labs that we've did. And we managed to get awarded 2 interims prize awards. So the 2 awards for really advanced robotic systems and imaging systems, which is really cool. So that's what from the ceremony there. So, so what is the thing that you need to do once you're on the moon? So what is the 3 pillars of our mission to the moon? So the 3 things are actually, number 1 is the journey. So how do you get to the moon? You have to cross a distance of 400,000 kilometers. And that's where we have developed our own spacecraft called ALINA. ALINA stands for Autonomous Landing and Navigation. So it's the usual fancy space acronym. And the idea of ALINA is to have a spacecraft which is capable of getting from Earth orbit to the lunar surface, down to the surface of the moon. From there on, we deploy our two lunar rovers, in this case, the 2 Audi lunar quadros, which will do all of the science and exploration. So they are the ones being mobile, driving around the surface for about 14.5 days. That's the time that they will spend on the surface of the moon. And what you do, and that's the biggest thing, earlier this year, in January, I had the big pleasure to meet Eugene Cernan. That was the last man who ever walked on the moon. He was the commander of Apollo 17, and I spent 2 days with him in Detroit. And I was talking to him about the mission, and he was telling me that it's not so much about how you get there and why you get there. It's about what you do when you are there. That's what matters. So that's the 3rd pillar of our mission. It's the science and exploration, really understanding what can you do for the benefit for all of us once you go back to the moon? So, and I will show you a little bit what is the focus for our mission here. So, how does this look like? Our goal is to launch in November 2017 on a commercial rocket into space. So let this sink in for a second. Today, really, we live in a time where you can actually commercially buy a rocket. So if you ever really seriously thought about shooting somebody to the moon, you can do it. It just costs you about 70 million. So if you have to think if it's worth for you. But this is nowadays an opportunity. So you have to think back in the 60s with the Apollo program. It was impossible, that is something impossible to begin with. They needed to develop all of the rockets starting out from 0. So they actually had rockets going up every week, but not going up in the air, but more like in flames. So it took them really 10 years to build rockets which repeatedly managed to get astronauts into space. But today, the commercial rocket launch market is something highly commercialized. So you can actually, send simple payloads up there. You can send your own satellite into space, which is really cool. So that's what we're building up on. So, so once you're in space, so then when your rocket drops you off, it drops you off into so-called lower Earth orbit. So, and the problem is, where do you go from there? Because you're still 400,000 kilometers away from the moon. So what we need to do is, from our case, is that our spacecraft, once it reaches the Earth orbit, it needs to do a lot of spherical, turns around the Earth. So it accelerates each time it comes by Earth and gets faster and faster and goes further and further away with each time. So, and the good thing is, at one point, you're fast enough and away enough to enter the gravity field of the moon, which is helpful. That means, however, wherever you screw up, you will end up at the moon in any way. Just might crash into it, which is in that case likely. So because you don't want to crash into it, you need to do kind of a precision trajectory. So really knowing the flight path that you take over to the moon. And what you can see here, it looks kind of weird, but you have to keep in mind that everything is moving in space. Both the Earth is moving around the sun, and of course the moon is moving around the Earth. So while we travel, everything shifts. So what we do is kind of, catching the moon, as you can see, at the end over there, and then trying to enter the right orbit around the lunar surface. So then comes the kind of simple thing which everybody always says, yeah, we just have to land there, because it sounds simple, landing on the moon. But this is actually one of the most challenging things to do right, because you have to understand that this traveling to the moon, you have top speeds that you reach of 10.6 meters per second. Think about this unit. We're talking about meters per second. So that does not give you much room for an error. If you have just one thing not working as it's supposed to be, let's assume you have like your thrusters, like one thruster decides that he takes a nap for half a second, then you are pretty far off already. Because, you know, with such a velocity, you know, steering becomes really, really hard. So for this landing, this is where we developed our spacecraft. And that's the very first time, by the way, that we show it in the public, by the way. This is the new third generation model of the Alina spacecraft. And we will show the real thing in 3 weeks at the International Air Show in Berlin. So this is what it looks like. And what you can see there is that on the two rovers, the two Audi Lunar Quadras, are on the sides, on the left-hand and right-hand side, in specific boxes. And what you also have is, of course, you have on the sides, you have a lot of experiments that I will show you in a few seconds what we do on the landing module. So the thing is, what you will notice is that everything we do in our entire mission is really optimized for weight. Because saving fuel is the only thing that makes this possible. Because you cannot cheat the laws of physics, but you can optimize what you do. So we really optimize every gram of the spacecrafts that we've developed. Okay, so yeah, but basically just without going into much detail, but the basic idea behind the spacecraft is that you have something, in this case it's for the first time a spacecraft which autonomously can actually get somewhere. So you just put what you want to get to some place from A to B, you just put it on board, and it can get you to the moon, drop you off. In our case, it gets us about 100 kilograms to the surface of the moon. And the interesting thing here is that it's a modular design, which means that it can be fitted into any rocket. Right now, we live in a time that when you're a scientist and you start out building a satellite that you want to shoot into space, then you're always kind of, the first thing that you do is you pick the rocket that you want to have, and you know, you design everything for the rocket, and then you know, at one point you want to launch with it. But the problem is that, you know, a lot of crazy things can happen. You know, you have like international politics, you have technological problems, so things can change. Your rocket can become unavailable. And this is kind of really an issue, because if you designed everything for a specific rocket, then you will have to redo everything again. So that's kind of an issue. And our idea is to have a spacecraft which is modular, so that you can really utilize any rocket that you can find, which again makes space a little bit cheaper from this point. So the question is, getting to the moon, where do you want to go on the moon? And in our case, we want to go to the moon to the Taurus-Littrow Valley. Taurus-Littrow is actually the place where we've already been, and that's for the first time in history of space exploration that we want to go back to a place, you know, where we've already been. So Taurus-Littrow was the place where we last set foot on the moon. It was in 1972, the Apollo 17 mission, and Taurus-Littrow had been chosen because it's a really highly interesting site from orbit. You know, we can look out of the window when you fly around the moon and you say that this is a site which looks geologically interesting. And our idea is to land about 3 to 5 kilometers away. So it sounds a little bit weird maybe to you that we want to land 3 to 5 kilometers away, but you have to understand that it's kind of shooting our spacecraft is either shooting a bullet from here, sitting on Earth, to the moon and trying to hit a really small spot. And our small spot is like a 1 kilometer ellipse. So it's really, you know, really accurate from this distance. So this is what and this is the exciting thing here. This is what the landing site looks like today. So, you know, for NASA, for about 3 years ago, NASA managed to send a probe, the LRO probe, which orbited the moon, which was something really exciting. It never happened before in a way. And they managed to do a deep flyover, as it's called. So they managed to scan the Apollo 17 area. So this gave us this image. So for the first time, we can ever see what the site looks like today. And what was really surprising to many people is that it looks like that a lot of the structures from the Apollo program, like the landing module and like the lunar rover, are still there and still standing upright. Because up to this point, scientists believed that everything would be like kind of fallen down, so that would be just like gray piles of dust being left on the moon due to all of the effects happening there, due to the crazy weather that you have in space. So once you're on the moon, what is the point on how to get around? So we want to land outside of Apollo 17, really like 5 kilometers, like if you saw on a map, like on the right-hand side. So, but then you need to travel these 5 kilometers, and that is where we've developed this Audi Lunar Quattro technology. And what is the special thing about this rover? So the rover, from the size perspective, to give you an imagination, it's like, from the angle, it's like this, and the height is about this size. So, and the special thing is that it has 360 degrees of movement. So meaning that from the top side perspective, you can go into any direction you want, which is pretty nice. If I would have this in a normal street car, I would totally love it, because you can actually park sideways. Just get to the parking lot and slide in there sideways. And the good thing is it has really no back and forth. So there's, in any direction, it has the same speed, the same travel speed. And of course, you can do the Michael Jackson moonwalk if you like to. Another thing about the system is that you have this 4K imaging setup. This is what you can see, the eyes of the rover. And the point is that these are capable of creating gigapixel panoramic images. So you can get a really good view in a really high resolution that has never been done before on the lunar surface, and understanding how the place looks like today. A special thing is for the rover itself is that it only has a mass of 25 kilograms, which really, really not much. And something that we've optimized it more and more with the guys from Audi Ultra to be more and more lightweight. Because this is the Generation 4 model, that's almost a flight model. And the Generation 3, for example, it had about 35 kilograms. And one of the big differences that we did from Generation 3 to Generation 4 was that we switched almost to completely 3D printed parts. So this rover is, to a large degree, made out of 3D printed aluminum parts. That's something that you can check out later a little bit after the presentation. So it's parts like these, which, it's something that you can do today, that you can actually creating out of a powder bed with lasers, creating parts which are really, really lightweight, strong, and they have their own mixture, of the composition. So that you can utilize them. Another thing about 3D printing is not just that you can create parts differently, but that you can actually create parts which would be impossible to create otherwise. So this is also one of the fields of lightweight optimization, is that you can actually, in this case, for example, this is a part where the cable routings for all the electrics or for the drives are actually inside the part already. So instead of having like 5 to 6 parts which are connected to each other, you have just one part, which, in this case is less error resistant. Sorry. So, and the other thing is that you can see on the slide already is that it's not really fast. So the maximum speed is really just like, the kind of maximum is like 3.6 kilometers. So it's definitely the slowest Audi that you ever have seen on Earth, but it will be the fastest one on the moon. So, and the point is, even though it reaches 3.6 kilometers, it's not, it does not mean that you drive that fast on the moon, because the point is, it's not about being the fastest on the moon, but actually drive safely. This is something that you can take to heart even here on Earth. But the point is that because there's no roadside assistance on the moon, so there's nobody coming to help 400,000 kilometers away once you get stuck there. So, sorry, I just need to fiddle with my microphone a little bit. Okay. So what's the special thing about the moon? So the lunar environment, we look at the moon as a really friendly neighbor that we have. So, and you have planets, when you ask people about complicated planets that you have, then people would say that getting to Mars is complicated, but actually getting to the moon is much, much more complex. And the reason for this is because, the Mars has something which is really nice. It has an atmosphere. The moon does not have an atmosphere. So that means that temperatures can change pretty, pretty wildly. In our case, we have a temperature fluctuations of 300 degrees Celsius. So meaning that once you're in the sunlight, you can actually, so once you're in the sunlight, you go to plus 120 degrees. And once you go into the cold area, then, yeah.
The microphone should be here. Don't bend it.
Yeah, but I hear an echo every time. It's okay? Okay, sorry. I was just confused regarding the echo, and I don't know how you can hear it. Okay, perfect. Okay, so the point is the temperature fluctuations. So that means the good thing is that you don't have any clouds on the moon. And the point is that, so if you would have a cloud, for example, then you would immediately cool down and heat up again once it's gone. So the only thing that happens on the moon is the lunar day and night cycle. So you have like the 30 days that you know from full moon, to new moon, that happen every 40 days. So, and the point is that this means that we have 14.5 days of sunlight and 14.5 days of darkness. In this darkness, it becomes really cold. In the sunlight, it becomes really hot. And the problem is that our mission is designed so that it can operate during the lunar day-night because we need the solar energy to work. And of course, because the temperatures in the, the -100 range would be way too cold for the rover to work. So it could easily, freeze down, for example. Okay, so another big challenge on the moon is actually the lunar soil itself. So the very thing that the moon is made of, the so-called lunar regolith. This first few surface meters of the moon, which is what we call the regolith layer, that's just like the sand on a beach. That's what you can imagine. The problem is that this lunar soil has a different origin than our sand grains here on Earth. So the lunar soil is, just from the type of it, it's from volcanic nature, meaning that it was created by impacts, it was created by volcanic activity. So the same thing, where, by the way, where our sand grains are created on Earth, initially like several billion years ago. The problem is that we have water here, so everything has been washed down and is really like small round pebbles. But on the moon, it's really, really sharp. So it's like shattered glass that you can think of, shattered volcanic glass. So, and another thing is, due to the fact that this is really sharp, it constantly shapes each other. So the lunar soil gets finer and finer every, I don't know how many years, but it takes, over the time, it gets smaller and smaller. So to give you a comparison, this is like the smallest particle that you have on Earth, and the side of it would be the lunar regolith. So you can see the big problem with the regolith is that it really gets into everything. So in our case, the challenge is to keep it out of the gearbox from the ALQ. So because if this regolith gets into the gears of the motor, it can immediately destroy the entire drive. So because, it really just gets down to the gear level and it works like a mill almost. And so the system destroys itself after a few just centimeters driving. So what we needed to do was to find a way to keep out the regolith of the rover itself. And to give you a comparison, the regolith was a big problem for the astronauts in the Apollo program. So, when they were walking outside, picking up rocks, and they're coming back inside their space capsule, they had their airtight suit on, so that they can breathe on the lunar surface. And once they took off the suits, they realized that they had this gray dust everywhere. They not just had it in their suits, but they had it under their skin. So they had gray hands, which is creepy, if you think about it. So NASA was really, really worried, if this, could do all kind of bad things like causing cancer or, whatever crazy thing moon dust can do under your skin. So, but this just gives you an impression how fine these particles are. So, and this is something where we have to make sure that it does not interfere with the technology. So, and I told you what's important is to know what you do when you're on the moon. So, what we want to do is that we want to travel not just this 500 meters that Google initially set out for this challenge, but we want to go much, much further. We want to travel 5 kilometers to visit the lunar rover of Apollo. So that's the vehicle that the Apollo astronauts to travel around the moon. Because, for once, it's one thing, if you're on the moon, then you can actually jump around, which is a lot of fun, like 1/6 gravity, and you hop and hop and hop. But the problem is it does not get you very far. So NASA, the Apollo astronauts came to NASA at one point and said it would be really, really great to have a car to drive around the surface of the moon. So NASA put together a highly improvised electric vehicle that the Apollo astronauts can use on the lunar surface. And this is one special piece of space hardware still sitting at Apollo 17. And I can show you why. Because the point is that this hardware, this has been scraped together pretty quickly. In about 6 months, they've built this first rover for the Apollo program to drive around the surface, and they really used all the parts that they could get. For example, if you look at it, that's the LRV. If you look at the chairs, for example, these are standard garden chairs that NASA picked up on a local market, on the roadside. So this is kind of the crazy things that they built back then because to be really, really fast to build it together. So you have really things like a lot of duct tape, you have like plastic, piano wire, leather, and, the garden chairs. So they're holding these things together. And the interesting thing for us is to go there with the rover and analyze what happened to it. Because from the NASA images from orbit, we already know it's still there. So the idea is to understand, which parts worked and which didn't. So this is really, really important from the idea of material science, because it tells you what parts you can use for the future of space exploration. What can you use to build your future homes on the moon? What can you use to build like an Audi where you can actually sit in and drive on the moon? Can you use like something like leather, or can you not? That's the idea behind it. So it's something really important. And you have to understand, this has been sitting there for 43 years exposed to the space weather of having every 14 days this temperature shift of 300 degrees Celsius, and of course all of the radiation and sunlight. So that's the number one idea, objective that we have, analyze what happened to the sky. So, and how do we analyze it? So the special thing is that we have this eyes of the rover that I already mentioned with these 4K cameras. But the special thing here is that the two eyes that you can see to the sides, they're exactly 8 centimeters apart. That's the stereoscopic cameras that we use. And 8 centimeters, that's exactly the diameter, the distance between your eyes. So between the eyes that we have as humans. So, and why do we have this distance? Because this enables us to see perceived depth. So I can actually tell how far something is away just by looking at it with two cameras. And that's the same thing that the rover does. So it does the same, it imitates the idea that your eyes do every day. So it helps us get a little bit better feeling of how far things are away on the moon. Also, it helps us drive, because this is what we use for the driver as the feet. When he sits in mission control, has a joystick, and figures out where to go. A special thing is the camera in the middle, and the camera in the middle is something which is called, it has a very complex name, it's called the multispectrum telelens, but it basically means that you have a lens which can look at the moon in a way that the human eye could never do. So in this case, we have 9 different infrared filters to see the moon in a way we've never seen it before. We can see the way that the resources are made up. For example, different soil reflects differently depending on what it's being made of. And the same thing applies to decay, for example. If you look at the lunar rover from Apollo with different infrared spectrums, then you will learn things. And that's the same idea that NASA used for the Curiosity rover. And the Curiosity had this very big eyes. It has this huge thing which was called mass cam. It's like the big box on top of it. And we miniaturized this mass cam and made it really small and fitted it into this camera head. So that's the special idea there. And all of these cameras that we've developed has a really low power consumption. So because that's something that you need to do, because we are much smaller because we're doing this privately, so we have to do this also in a way that it's financially feasible. And that means that we have to do, don't build rovers which are so large that they're bigger than yourself, but actually which they can fit in a very cost-effective rocket. So that means these cameras are also optimized from the size. Normal cameras for space, they're like this big, and they take lots of energy and just only take up 1 watt of energy. So what is the three main things that we want to achieve with this? The 3 main goals that I have, and that I personally think are really inspiration for us, they are mixed with the technology we have, but also with the things that you can accomplish when you go back to the moon. The number 1 thing is that we want to preserve the knowledge and the legacy of mankind for eternity. So how do we do this? 2 weeks ago, we announced a partnership that maybe some of you have already seen with Wikipedia. So Wikipedia, when you log on to Wikipedia, you will see a banner which says Wikipedia to the moon. And we've partnered with them to work on creating an archive for the knowledge of mankind to be preserved for the future. So really understanding, having a way, and this is the complicated part there. So figuring out what, of the knowledge that we have today would be interesting for either the future reader, whoever this might be. This might be aliens, or this might be future humans, whoever picks this up. And the idea is, to pick up what to include, and then, of course, create the manual to read it. Because how do you bring this data up there, and how do you store it for 1 billion of years? And that's where we're researching and working with a lot of scientists around the globe to have technology like this. This is a very special crystal that we use to preserve this information in a digital way. So this, for example, this crystal can hold several hundreds of gigabytes of data. But the problem is, how do you explain to somebody that you don't know, that you have never met, where you don't speak his language, to read this data? So that's the challenge there. So really, having like a universal language and having like a tutorial, for somebody to understand what you do there. Another thing what we want to do, and it's simply being said, but it's one of the huge, huge things, we want to grow the very first plant on the moon. So the first time when I was sitting down with NASA and they was proposing this idea to us, it was really quite, not amazed, but actually kind of, I was a little bit startled because, NASA was explaining to us that they have the idea of putting a habitat on the moon and growing a plant there and see how it grows. And it was like sitting there in the audience and was thinking like, yeah, but, why shouldn't it work? Why shouldn't a plant grow on the moon? And this is actually something where they showed me what happens when you try to grow plants in space right now. And the interesting thing is plants in space, seeds that you grow there, they actually get kind of confused, as you would call it. Being confused in a way, and the current theory is that they don't know what to do because they don't know where is up and where is down because for example, on the space station, there's no gravity, so they just sprout open and, then they don't know how to continue because they don't have any idea where's up, where's down, where to put the leaves, things like this. So that's a big problem because if you think about the future of space exploration, then growing things in space is actually pretty important and really nice. So the idea with this experiment is to showcase that the #1 issue with growing plants in space is actually the lack of gravity. So, and the good thing about the moon is that we have 1/6 of gravity. So if this works, this tells us two very important things. This tells us that the problem for growing plants in space is actually gravity, and that 1/6 of gravity is already enough to solve this issue. And of course, it would show that you can grow plants on the moon, which is a huge thing for the future, if you want to, start off the moon. So that's one big thing there. So by the way, the experiment itself will be, can get to see the first results already after 2 days. And the special thing there is that it's a so-called open experiment, so that we will be sending out kits, small sets to school classes all around the world so that people can actually redo the experiment in parallel to it happening on the moon, which is really, really exciting to see if their plants, for example, grow or if the plants on the moon don't grow, for example. And the last but really important thing is that we actually want to pave the roads of the future. So there's some really strong visions out there for what you can do on the moon. And one thing, one of these visions, for example, is made by the European Space Agency, is the idea of having future human settlements. And this is something that they were thinking about in the late 2030s. So, but what we found is that if you want to dream big, then you need to make the first step. So what we looked at, what we can do with the Audi Lunar Quadro rovers that we have right now, is that we want to include an experiment, which is a very special one. If we want to, in simple terms, 3D print for the first time a part on the surface of the moon. So we want to use the lunar dust, which I told you earlier is really not the most friendly way that you encounter something in space. We want to use this for our benefit and actually create the first man-made object on the surface of the moon. So, and the idea there is to use a small microwave beam to melt it. This is something that only works on the surface of the moon and only with the real thing, with the regolith. So, and the problem is, 3D printing here on Earth takes up a lot of energy. So, and the problem, energy is something that we don't have on the moon. On the moon, we have like, we only have like, like a few hundreds watts, and that is not sufficient to get enough power output to melt something like silicon, for example, which is what's the main part of this lunar regolith. So, and the beam technology will be something really interesting to see if we can demonstrate to actually glass a simple part of the surface area. So it will be quite interesting. And then you can actually show that you can create structures on the surface of the moon. So, and if you showcase that you can actually make use of the resources of the moon, like using the soil right there, and using, for example, things like the parts in the soil, then you can actually use the moon as a jumping stone. Just one thing to mention is because most people don't know it, and I've been doing this for 8 years by now, so I kind of take this for granted. But what most people don't know or expect about the moon is that actually there's water on the surface of the moon. So that's something, initially in the 60s, everybody was believing that the moon is just a gray powdered rock, dry and just with sand there. But What's turned out to be the result, I think 3 to 4 years ago, as a discovery by NASA, is that the moon does not just contain water at all, it contains a lot of water in the form of ice deep below the surface. And part of also what we want to look at is to figure out how to make this water usable. Because if you can utilize water, if you can make it tap into the water on the moon, then you actually have water, of course, to drink. From water you can derive oxygen, which is nice to breathe, you know. And if you have water and oxygen, you have all the ingredients for rocket fuel. And if you have rocket fuel on the moon, if you have water, you know, air and rocket fuel, then what is the moon for you? The moon becomes like your gas station on the highway to space. And that is how we see it. And that's a good thing about, you know, all the bad stuff about the moon, you know, being, you know, that it has no atmosphere and only the low gravity, actually in this case becomes a good thing, so that you can actually use the moon as a starting point. You can actually build a spacecraft there out of the parts of the moon, or maybe pre-assemble some parts there, fuel it up and launch it towards Mars, which is kind of the big vision there. So yeah, that's what we see ourselves, where we want to contribute as best as possible. So yeah, thank you very much. I hope I wasn't too technical in the presentation, and I'm really happy you have some questions. And also check out our website at missiontothemoon.com with a lot of infos about what we do. Thank you.
Thank you. Thank you, Robert. We don't really have time for questions, but you can send the questions on Twitter, and I'm just going to ask you one question to wrap it up here. What do you think is the single biggest challenge to the mission you're trying to launch here? What's the hardest thing?
Yeah, that's the funny thing, actually. Everybody always asks, what's the most challenging thing? And the problem is, you know, I'm the guy who founded the team, so I'm the team lead. So, and the point is, if I'm in my office at home and I go from door to door to door, I can ask everybody, you know, I go to the mechanical engineers and ask them, hey guys, what's the biggest challenge to Jürgen, you know? And he will come up and say, oh my God, yeah, all the gears, all the regolith, and the temperature, you know, happening to it. And then I go one door to the next, you know, to our electronics guys, and ask them, hey guys, you know, what's the biggest challenge? And they say, oh my God, we have 500 times the radiation on the surface of the moon. You know, you have to develop chips that can withstand it. So the answer is, everything is challenging, and there's almost no room for errors. As I told you, we have travel velocities of 10.6 meters per second. So really, there's not much time for errors. So everything has to work for the mission to be a success.
Okay, great. Thank you very much.